Hello everybody and welcome to the Team 12 presentation of the Capstone Design 2020. My name is Urmil Bansali and I'd like to start off this presentation by asking you guys a question, a hypothetical scenario. Imagine that you had a date coming up, or imagine that you had something else that is really important coming up, say like an interview, and you want to look your sharpest. You don't want all this long hair to be there, right? Or imagine you're in quarantine and your hair is all really filthy. You go to the barber and then you expect yourself to look really nice and really sharp, but this barber hasn't cut your hair before and you don't know what he can do to your hair. So what do? You go to the barber, you spend 20 minutes driving to the barber, you spend 20 minutes or 30 minutes sitting over there waiting for somebody else to get done, and then you take the risk. You've decided to take the plunge, you're going there, you're sitting there, you hope that he's going to do a good job, but what ends up happening is that you end up looking like this or like this, and now you're frustrated and you're probably not going to get that second interview or that second date. This is why we created the Smart Hair Clipper. The Smart Hair Clipper is basically a device that you can use to cut your own hair at home. It works by tracking its position relative to the head, and it can change its length according to where it is located. For example, if it's located here, you might want shorter hair, and if it's located here, you might want longer hair. The way it works is that we connected a camera to a Raspberry Pi that was taking a continuous video of the person and the trimmer going across his head. Then we process that video to send instructions to the trimmer in real time to say, okay, if you're at this position, I want to cut the hair to this length, and if you're at that position, you want to cut the hair at that length. We attached a servo motor to this clipper so that it would help us move the guard of the clipper accordingly. There were two main parts to this concept. One was the tracking, and two was the device itself.
To know what position we want the guard in, we use optical tracking to find the position of the trimmer relative to the head. This gives us an idea of the region of the head we're cutting, and based on that, we can alter the guard length. We use a Raspberry Pi 3 Model B as our microcontroller, which reads an attached camera whose image gets analyzed with Python code utilizing the OpenCV and NumPy libraries. This code will first detect the position of the trimmer within the frame, then it will find the bounding box of the head, hair, and shoulders of the user. Finally, it can find the relative position of the trimmer within the box given a measurement point it can then use to control the trimmer. For the first step, setting the trimmer position, we tape a marker to the trimmer of a distinct color from the environment. We extract the color of the marker from the point of view of the camera we're using, and then when analyzing a frame, search for a small area with the smallest distance in color from the marker. A point in this area becomes our trimmer position. Finding the bounding box of the shoulders, head, and hair is a little trickier since we need the entire box and not just a point. Our code uses an algorithm called GrabCut built into OpenCV to efficiently separate out foregrounds and backgrounds of the image. As an initial input, we design an initial mask, which we internally call bullseye, which tells GrabCut how likely we consider certain areas to be part of the foreground and background. The image needs to be designed based on the angle and position of the camera relative to the head, so that GrabCut knows we're looking for the head, hair, and shoulders, but not parts of the background. GrabCut will classify each pixel in the image as being part of the shoulders, head, and hair we're interested in, and from there we can find the bounding box. The GrabCut operation has to be done on a scaled down image, since the image we get from the camera is too slow using GrabCut. In our current version, with enough scaling, we get about 10 Hz on the Pi. Ideally, to get an all-around haircut, we want to have multiple cameras giving measurements from different angles. Even with the performance constraints, we believe added parallelism would have made this feasible, but lockdown restraints required us to simplify a bit, just focusing on one camera at a time.
So this right here is the conventional hair clipper where I have integrated the servo motor into the original body of the clipper. So I have completed the 90% of the integration, and only part that is left is the gearing or the teeth of the gear that will go on the bottom of that will go into the moving part of the clipper so the length can be adjusted precisely. The specific clipper came with two different guards two of these, so they can be interchanged for greater length options. But in our project, we'll be using only one because the servo motor allows us to make greater adjustments with a little hardware tweaking as well. So I'll show you right now how the guard can be inserted or taken out for cleaning purposes. So it clicks into place like this. So as I mentioned before, underneath the clipper, which is this part right here, this is how I integrated the motor. And right here, this will be the moving part, so the guard will be adjusted. So the missing gears or teeth of the gears, which I was not able to get because of all COVID-19 situation. So the moving part, the way it will work as the motor moves, this is how it's gonna go forward, backwards, and this is the side view, same. So as of right now, the adjustment length is 0.5 inches or 1.28 centimeters. This length starts from 0.5 millimeters and go up to 1.28 centimeters. So we can increase this later if needed, but I think this length is pretty much good for now for testing purposes and everything. So the way we can make these adjustments is that the servo motor rotates for about 180 degrees, and according to the position of the clipper respect to the head, correct degrees can be set so that we can get desired haircut style. The clipper will be charged using the original charging port, which is located at the back right in here, and the wires coming at the back are the wires that will controlling the servo motor. So I have left the connectors at the back of the wires so we can extend these wires because we're gonna need this for when we go around the person's head, so the length will need to be increased. So this concludes the hardware implementation and design. Thank you.
Okay, so now let's talk about the initial concept that we had envisioned as a team. So first let's talk about the tracking. For tracking, we had actually thought that we might use a combination of 3 different technologies. We thought that we would use Bluetooth Low Energy, inertial sensing, and an optical tracking system. We were trying to find out what the most feasible option would be. So let's talk about inertial sensing. So we thought that we could use an inertial sensor along with the optical tracking system to help us detect the position of the trimmer more accurately. The inertial sensor would have given us data such as the acceleration and the angle of the trimmer at that point in time. And since after testing our device and seeing what the level of accuracy that we were getting, we thought that we didn't really need the extra accuracy at that point in time. And we thought that we shouldn't over-engineer the product, but keep it as simple as possible. So in case we were to take it to market, this would be a simple idea. Also, Bluetooth Low Energy was not accurate enough, and for the same issue of not wanting to over-engineer the product, we chose not to go with that either. 2. Let's talk about the positioning. So if the camera was located on the side and we were trying to see where the trimmer was on the side of the head, we could have easily done so. And so is the case even with the back, because the camera doesn't need to be behind the head, but it can be on the side and detect everything that is happening on the back of the head like you saw in the videos. Lastly, let's talk about the moving of the person himself. So if the person looks left, right, down, or looks around while he's doing the haircut, that is really not an issue, because as time is going on, we're constantly refreshing the location of the head itself, and the position of the trimmer is relative to that position. Therefore, we always know what the position of the trimmer is relative to the motion of the head, which means the motion of the head shouldn't count as much. Now let's talk about some more interesting questions. Let's talk about the haircut itself. So will this actually give us a good haircut? To understand that answer, we have to look at what our target market would be. This product we thought would be used for people who are mainly at home. So maybe someone who's injured and can't go out for a while, or maybe someone who's bedridden, or even old people who really don't care about all the nicks and knacks of the fashion at that point in time, or the trends and doing fancy things with their hair. So people essentially who just want a really simple haircut and want to go on with their day-to-day life. but that is definitely not to say that this device would not give you a good haircut. The sides and the back would be done extremely well, but the top of the hair might still be a little problematic. For that, we were actually collaborating with the barber on Easter Avenue, and he was willing to help us with this technology, but unfortunately, because of the COVID-19 crisis, that couldn't go through. We believe that the smart hair clipper that we have created can give stiff competition to the trimmers of today. This is solely based on a cost comparison. If you were to pay the same amount of money or less money for a product that gives you this functionality versus a product that does not, of course you would pick the extra functionality. That's just common sense. This is the cost breakdown. You can use your own phone camera to sense the device, which would essentially be free. On eBay, we found a bunch of servo motors for $1.29 each if you buy it in a bulk quantity. We believe that the manufacturing cost would be a one-time cost, which would be high in the beginning, but would be recuperated once the business goes on for maybe 3 or 4 years. And lastly, we found generic trimmers on Alibaba.com, which is a wholesale website, for about $10 each. So with the average cost of a haircut in America being $28, this is a significant reduction in price for every single haircut that you want. To conclude, I'd like to say that we finished most of what we had intended at the beginning of the semester, despite the crisis. Because of the crisis, we couldn't get the gears delivered in time, therefore we could not actually make the part that moves up and down. But other than that, we finished most of what we wanted. If this project goes more than a semester long, we would like to have created an entire app that had preset hairstyles that you could just select what hairstyle you wanted and it would move accordingly. But since there was not enough time, this is what we could produce. We hope that you enjoyed the video, and we hope that everybody is safe and also enjoying this time in quarantine to bond with your family and do the things that you didn't get to do before. Thank you.